Thanks so much for having me. I'm Samuel, as you said. I am best known as the creator of the Pydantic data validation library. I now run Pydantic the company, where we continue to develop Pydantic validation, but we also have Pydantic AI, our agent framework, and Pydantic Logfire, our observability platform. When I came to reread my abstract for this talk, I thought it read rather more like a kind of revolutionary call to arms than a keynote talk. But as I continued to think about this particular subject, I kind of convinced myself again that we are at a crossroads in how we develop software, and it is important. And so what I want to try and do today is convince you of three things. Firstly, that we are at this crossroads in terms of how software is developed, deployed, managed, et cetera, and who manages that and how it's managed. Secondly, that we already know which route is better, or at least it's obvious which route might be preferable. And thirdly, that this is not a philosophical or political discussion. Some of you may be relieved to hear. It's about practicality and pragmatism and engineering good sense. And therefore, it has a real impact on developers day to day, rather than just being some kind of high-level conceptual debate. So first, are we at a crossroads? I'm sorry if the chart on the left is slightly hard to read. All it really says is, as we kind of all know, use of LLMs is, in this case, chatbots is centralized amongst a small number of companies. That, I don't think, is inherently a bad thing. I think that given the cost of building these models, it is completely natural and, as I say, perfectly healthy that there are a small number of companies who are doing that. I think it's good it's not one, but the fact that there's a small number is not a problem. What is, I think, stranger and more concerning is how they are moving from just being an API, the inference rails on which people go and build their application, to being the everything stack or the everything platform. So we know they all have consumer chat applications that are very important to them for revenue reasons. They have the equivalent functionality in enterprise. They have things like deep research, so chat can go further. Then they go a lot further than that. So we have more and more of these built-in tools, like search, code execution, database and document lookup, that are basically taking stuff that would previously have at least been controllable by the application and pulling it into the platform. Even OpenAI, for example, even have tracing within their platform. So again, trying to pull everything inside their platform. They all have agent frameworks of one sort or another. None of them are as downloaded as Pydantic AI, luckily, at the moment, but they are definitely trying in that way to use that as another moat. And they're obviously, as we've all heard recently, even going into like visual agent builder space. So it is my belief that in the desire for profit, or at least marginally profitable revenue, they are forgetting the lessons we learned about in the past about how to build software and trying to centralize everything in these platforms. And while that might be advantageous for those large companies, it is not advantageous for us as developers, or for end users, or for the community, or for the industry, or ultimately for everyone who is going to be a consumer of AI, which seems like it's going to be more or less everyone, at least in the developed world, pretty soon. So it's almost as if Visa and MasterCard were not content with building the payment rails on which people then built companies. They had to go and build the supermarket or the online marketplace themselves to basically control more of the stack vertically. For this to be a crossroads, for this to be a choice, there have to be multiple different solutions. And so the second part of persuading you that we're at a crossroads is to say that there is an alternative. And I think there are really serious, credible alternatives to everything living within the big AI labs. So we have open standards and open protocols, which are wonderful and allow us to do lots of things without having to basically hand everything over to the foundational model labs. So we have MCP, Model Context Protocol, in that case from Anthropic, thank you very much, which allows us to give effectively context, tools, resources, and prompts to an LLM in a way that is agnostic of what model you're using or even what framework you're using. Tool calling has existed since long before built-in tools and is arguably much more powerful in many cases than the built-in tools. Definitely gives you more freedom as to how you want to implement, let's say, web search or code execution than using the built-in options. Agent frameworks, of course, like Pydantic AI, but we're by no means the only one, let you build AI applications that can be completely agnostic as to what model you use, or at least allow you to switch the model in one line of code. So when a new model comes out, or when someone does a price hike, you can switch model very easily. OpenTelemetry is a wonderful, well-developed, mature, open standard for observability that allows us to understand what our agents are doing, understand where they're slow, where they're behaving badly, without having to lock ourselves into one provider. So it effectively allows the framework or the application that's emitting telemetry or observability data to be independent of the platform you're using to view that data, search that data, analyze it. Protocols like AGUI and Vercel AI allow you to separate chat applications from the agent or the system which you're interacting with, so that we can have a state-of-the-art UI that we build on top of our agent in a few lines of code, rather than having to go and build all of that and the protocol that sits between the two. And the list goes on. Another example you might think about is evals. We've had the need to measure the performance of stochastic functions for years. We have lots of great primitives, even libraries for that. And yet people are, particularly in the big labs and in some startups, trying to reinvent the wheel on that stuff. Durable execution you could think of as another one, where we have agents that run for a long time. That is not a new problem in engineering. And that's kind of our big thesis at Pydantic. AI is still just engineering, and we have solutions and understanding that can cover lots of these problems. We don't need to reinvent the wheel or centralize everything into a few companies. The second point I wanted to convince you of is that we already know which route is better of the two that are out there. So why do startups beat incumbents? Well, often they don't, but if you have enough startups, someone will have the great idea. There will be one amazing founding team. Someone often will go and beat the incumbent. Why does the scientific method work so well? Why did capitalism, for the most part, eclipse communism, at least as a philosophy? And of course, the ultimate example when you talk about these things, the internet. What do these all have in common? Because they have in common that we so often don't know the answer. And if we can take a check of our hubris occasionally and remember that, we realize that we need multiple different shots on goal to try and find the solution, rather than anointing one particular solution or one particular leader for a given problem. So it's the same reason that, in general, demand-driven economies are more successful than command-driven economies, because you get lots of people trying to solve a problem. When one of them gets it right, you can go to that, and if they then eventually drop the ball, you'll have some competitor waiting in the wings to come and take over. Whereas in a commands-driven economy, a situation where one person is choosing what solution to go with, it's too easy for that solution to go wrong and you not to have an easy backup available to you. It's fundamentally about a meritocratic system rather than anointing a leader or a single solution. So that all sounded very philosophical. So I want to make as a third point, I want to draw this back to something much more practical and day-to-day for most of us. So let's go back to 2015, and I go back this far because I want to talk about an example where I think we all kind of can see what happened, that we've had the dust has settled. We can see now in retrospect why one solution ended up being, in general, much better than another one, which is kind of harder to do with stuff that is in our immediate past. So I was just getting into software development back in 2015, and I remember even at the time being kind of surprised that there were these web frameworks built by massive companies like Microsoft, and yet there were these open source alternatives like Django, and very quickly you realized that Django was a way better solution. Why is that? You would have thought Microsoft had all this money, all these resources, all this control of all the different bits of the stack. Surely they would build a better solution. And of course that wasn't true, and it wasn't because Simon Willison and the other people building Django were predestined to succeed as geniuses, although I think what they did was great. It was because there were lots of different people building web frameworks. Most of them probably weren't that good, but one of them turned out to be great. And that is what you don't get when you have this kind of command-driven systems. And so you can, and the other thing you get when you, in open source, one of the things that reasons that open source works so well is that you have separation of concerns, and you have people trying to target one particular thing and do it brilliantly. So sure, the Django developers were not going to go and build the best library for parsing HTTP headers. They were not going to go and build the best database, but they were able to use Whiskey as a protocol to take care of the HTTP parsing. They were able to go and use Postgres and MySQL to be the database. All they had to build was the web framework that sat in between. And indeed, we've moved further on since then, and now generally you would use something like Fast API, where you've separated out even the database connection from the raw web service. And of course, the other main reason that Django won was they cared about developer experience a lot from the very beginning in a way that is much harder to mandate when you're inside Microsoft, where you've chosen one answer and said, this is our web framework, this is how it's going to work. And sure, you've got more resources to go and put into optimizing the routing algorithm, but you can't kind of buy the taste that is needed to build something with great developer experience. And so I think we're in a similar position here. It just, for me, boggles the mind that people have forgotten these lessons from not that long ago and are going back to the ASP.NET, we're going to have one company who will offer you all the things, and don't worry, I promise you they'll all be great. Yeah, do I really need to tell you which is nicer of ASP.NET or Django? The numbers, I think, say it all, that for the vast majority of people who have the choice, Django was a far better way of building than using the full Microsoft lock-in stack, as it were. So to kind of clarify those points again, software is changing. The way that what applications do, how we build them, and how we deploy them is changing faster and more profoundly than has happened since the internet, maybe ever. I would say probably more likely since the internet. And we do have some choices about what that future will look like. And I encourage us all to think about it and try and choose which of these paths we want to go down. I think which solution is better is relatively clear to me. And again, it is fundamentally about practicality, not about philosophy or politics. It is a practical choice of whether you want to do the thing that makes most engineering sense or the thing that makes most economic sense for a small number of companies. And so I'm going to finish with a kind of code sample of Pydantic AI. I'm not going to expect you to read every line of this code, but I put it here to demonstrate what I'm talking about. So this is Pydantic AI. I think it's the best agent framework right now, but you can choose to disagree. But the point I want to make here is the logfire code you see at the top here means we're instrumenting this agent run with OpenTelemetry. We're emitting the data by default to logfire, our observability platform, but you can send it to any platform you like because it's just OpenTelemetry. So we are economically incentivized to build a great platform rather than say we have lock-in because we're using a proprietary protocol, so we don't need to actually invest in building a great product. We're doing structured data extraction using the standard Pydantic library. Again, that even uses open standards, so in that case we use type hints to define the schema. People have loved that and have done since we first built it way back in 2017. Next, we've got an MCP server that we're going to connect to, so we don't need to go and implement all of our tools or embed ourselves in an ecosystem or embed ourselves in one provider to have access to an easy way of accessing context. We can just use MCP to connect to basically everything now, right? As in very quickly, it's become the default for how you give context to your application. And there are MCP servers for lots of things, but you can also go and build your own. Yeah, and then lastly, here we're using OpenAI GPT-5, but fundamentally you have a choice of more or less whatever model you want. You can change in one line of code from OpenAI to Anthropic or to Google or to Grok or to Mistral or whoever else. And so the proprietary protocols within the API that I think the big model labs hoped was going to be one of their moats becomes a minor headache for some people inside companies like Pydantic rather than an actual barrier to switching model for end developers in general.